So here we'll start with the current mirrors. Okay, in the previous lectures we have seen the biasing. Now there we'll get 2 to 3 marks, and again this current mirror has some weightage of 2 to 3 marks again. Okay, so we cannot expect how many questions we'll get from the current mirror, but definitely one question we'll get. Okay, that is for 2 marks or 1 mark. It might be. Right. So what is current mirror? It's saying current mirror. That means if I give some current at the input side, okay, or else if I give some current at this point, at the reference point, I need to get the same amount of current at the output point. What I should do? Okay, that is called current mirror circuit. Okay, in order to get same current which I am getting at this reference at this point, then I need to form a circuit called current mirror circuit. Okay, for that reason we use current mirrors. What does it do? Generally these current mirrors have some gain, they produce some gain, and so they're mainly required to maintain the current same in the, suppose now we consider an IC, there are multiple transistors, but overall the current should be maintained. Okay, the same current which we are giving at the input should not be distorted to get the output, to get at the output. So for that reason these current mirrors are used. Okay, the famous current mirrors are Wilson current mirror and Whittler current mirror. We'll talk about them. Okay, but before going that, I need to give you the basic explanation of this current mirror. Okay, how I thought to give it. So what I'll do is, first thing I'll separate this current mirror circuit and I'll explain it. Okay, first I'll separate this current mirror and I'll explain it. So I'll take first this transistor, this part of the transistor I'll take. Okay, right. Consider this part. I have the reference. Okay, I have a transistor here. Okay, and this NPN transistor. Base and collector both are shorted. So this is my first circuit here. I'll call it as Q1 transistor. Okay, so generally for NPN transistor we know we apply some voltage VBE1, and it will be VBB1. So for this thing, this thing is called diode connected circuit. This circuit is called diode connected circuit. This is important. This is called diode connected circuit. This is one type of biasing we did. Okay, by seeing the circuit only you need to understand this is called bias connecting circuit, diode connecting circuit. What is the current through this? This is IC. Okay, what will be the current through this thing? That we need to know. That is simple. I'll say it is 0 amp. For these kind of problems, whenever they have given, for this beta is high. Okay. The fundamental concept we need to know before applying the current mirror is, in current mirror both the transistors or number of transistors which we are using, they all will be in active region only. Okay, for the good current at the output, for the good current to get at the output, the transistor should be identical. Okay, so then only we can produce the replica of the reference at the output. If not, there will be some mismatch and you won't get the required output at the output terminal. Okay, first thing, transistor will be in active region. Second thing, they should be identical. Okay, identical in the sense area wise, or else same VB should be applied for both, same current should be there. Okay, same chip area should be there. Okay, right, then only we can get the output at the correct path. Now here beta is high. Okay, generally we consider. Now if you can see here the circuit, I can say IC is I reference, then directly, because it is connected here. This is VC terminal, this is base terminal. What will be VC be? VC minus VB. Both base and collector are shorted. That means both are the same potential. That means this is equal to 0 volt. 0 volt. No current is flowing through that. So no current means entire current I reference which is flowing, that is under IC only. So I can say IC equal to I reference. Am I right? Now another thing, As beta is very high, IB is 0. Okay, you forget about beta is high. As both are short circuited, IB is 0. Whenever IB is 0, what is IE? IE is IC plus IB. Whenever IB is 0, IE equal to IC. That means they are also same as IC. They are also same as IC. So this is generally called diode connected circuit. So here what we do is we use the concept of current in diode. Okay, this all will be equal to I naught. I naught is the reverse saturation current into e power VBE by VT. VBE by VT. VT is called thermal voltage, that is 26 millivolt at room temperature. VBE is the voltage across this. Here as it is first transistor, I apply VBE1. So I'm clear, I think. Okay. This is a diode current. You remember this, very important. Whenever in analog circuits you are doing any problem, if the diode current is very important, I naught equal to I difference equal to I naught into VBE by VT. Okay. Now, generally that VBE will be VD in the diode circuit. Okay. They will give the cutting voltage of the diode. That will be there. Right. So I got I reference as VBE by VT. Am I right? So here I reference is I naught into VBE by VT. I naught is reverse saturation current, not the output current. Please remember. So in order to get my VBE or VT, what I should do? Apply logarithm on both the sides. What happens? When I apply logarithm of both the sides, I get I referent by I naught. I apply log. I apply log here equal to. When I apply log for e power, what it will be? VBE by VT. VBE by VT. I got it? This is the first one. I'm sorry. First. So VBE1 I say. VBE1 I say. So you send it there. VT into logarithm of I reference by I naught. This is the first. You let it be first equation. This is VBE1. Okay. So one part is over. I will take that part now. I'll take that part. This will be one. Here. This is general circuit. That's it. What is available there? That is. So here current is 0 in the previous circuit. No current is flowing here. So even here there will be no current. IB equal to 0. So beta is high value. You can say okay. Beta is high value here. Whatever it might be. So this is IC here. This is same as I out here. IC same as I out. Whatever I am taking is that. Okay. Whenever beta is high, this is IE here. Whenever beta is high, IC equal to IE. That is equal to I out here. Again the same diode equation. Okay. IC equal to I out equal to I naught. This won't change. This will change. VBE2 by VT. Okay. Now let it be I need a relation between I out and that thing. So I will mention it as I out only. Okay. Let it be I out. So here I out by I naught. Apply logarithm on both the sides. Then I get VBE2 into VT. Into VT. Okay, so I got into VT here now. So this is VB1, this is VB2. Okay, so again, now consider the entire circuit. Consider the entire circuit. Whenever I consider the entire circuit, then first case, you assume cases now. Assume the cases. Case 1. If VB1 equal to VB2, VB1 equal to VB2, what happens? VT logarithm of I reference by I naught equal to VT logarithm of I out by I naught. VT cancel. Okay, VT is cancelled. Now after that, logarithm is cancelled again. What I get is I reference by I naught equal to I out by I naught. Okay, ultimately I am landing at I out equal to I reference. This is the important thing. I out is same as I reference. I got it. This is a current mirror equation, that's it. At the output I have I reference. The input should be same as the output. Okay, this first case I am saying for the basic current mirror. Now the second case. This is interesting. Very interesting. Okay, now if case 2 if beta is not infinity, then see, beta is not infinity, what happens here? The current here is IC, as usual. After that, if beta is not 0, then this current is IB. I'm sorry, this current is 2IB. How? Because here it is IB, here it is IB. Leaving current should be entering current, 2IB. So here what happens? What is my I reference? That is IC plus 2IB. Am I right? IC plus 2IB. So according to that, and here what we got? I out is equal to, here when we apply, remember here beta is not equal to infinity. That means here what happens? We have IB here, What is I out? That is IC. Okay, so you convert it here, 1 second. Here you convert it into beta IB plus 2IB. This is beta plus 2 into IB. Am I right? This is beta plus 2 into IB. Yeah, this is the first. Now here, what is IC? Beta IB. Am I right? For general circuit, that is beta IB. So I'll say this IC is I out. Now divide it. I out by I reference is beta by beta plus 2. Am I right? Beta by beta plus 2. You send the I reference that side. You send it. That is I reference. हो गया. This is the second case here. Whenever case 2 beta is not equal to infinity, then I out equal to beta by beta plus 2 into I reference. Okay. Now again next case. Case 3. This is very interesting. So here, whenever we have a transistor here, it have junction. Okay, it has junction, emitter junction. Okay. Now here what happens is, whenever the area of the chip is directly proportional to the current. This is very important. They have asked one question also here. Okay, the area of the chip is directly proportional to I naught here. Okay, then what happens to the I out? Okay, here whenever area is multiplied by, if we remove the proportionality, k times I naught. If we remove the thing, it is k times I naught. Okay, but whenever it is multiplied by k times I naught, then what happens? Here is I out will be k times I reference. This is important here. Whenever you are multiplying it with this, then I naught will be k times I reference. If area is increased, I naught will be increased. The factor that is multiplied here. Okay, I will take an example, then you will understand how to manage this kind of problems. Okay, don't worry, we'll see when it comes to the problem side. Okay, so these are the 3 factors. Okay, and next is the very important thing. Next 2 cases are important. Case 4. This is a basic current mirror. uh, should I write should current mirror be like this only? Only this only case? If you ask such a question, no. We have another case. Like we even can denote it in other way also. As initial, before this circuit, there was supply here. Now I grounded it. I applied negative supply here. Now even this works as a current mirror. We'll see how it works as a current mirror. Okay, it works as a current mirror. That's it. No worries. But here what we need to know is for beta equal to infinity, as we know, for beta equal to infinity, what is iot? Iot is I reference. We need to know this I reference. That's it. What is I reference? Apply the loop here. Take down. Your wish. You come in internal also. You can apply internally. Okay, because internally it works. Okay, because no voltage outside. You don't know anything about outside. Start here and reach here. What all we know, you put it there. So the starting is I reference directly. It's a current, right? Okay. Now beta is infinity. There is no current here. There is no current here. So I reference equal to this current. So I reference equal to VBE. Okay. What are plus VBE? VBE. This is leaving current. Okay. Okay. Right. VBE minus VE. Then in the place of current source, okay, in the place of current source, I'll mark a resistor here. I'll place a resistor here. Although I place the resistor, the same current flows here. I reference. I consider this to be I reference. Okay. So VB minus VE by R. This is a negative current. It is leaving from the ground. Okay. Now, so this should be I reference is VEE minus VBE by R. This is equal to iot. This is case 4 problem. This type of questions they ask. Just change the supply, that's it. No need to confuse. Not to get confused, okay? Next. We have case 5 next. Similar kind only, but here, next case what we do is apply the VCC and VI. Okay? Here I am applying VCC. Here it is VE. The same question. Now what happens? Again, iot will be same. I reference only. But what is that I reference? That is important. What is important? Start from there. What we have? Minus VCC plus I reference into R plus VBE, and I'll encounter minus VE right directly. Okay, so minus VEE equal to 0. Need to say. Okay, so that's it. Okay, now I have to get I reference, right? So this will be VCC minus VBE. Am I right? I'm getting the current from there. Okay, apply I reference is this. This leading current. That means it minus here. So this will be VCC is coming up. It's positive. It is negative. Okay, that is correct. So here VCC plus VBE. Okay, minus VE by R equal to I reference. Did I do any mistakes? Please correct me if anything is wrong. It's coming from VCC. Okay, so it has plus only. It is coming from positive. Okay, this is negative end minus VCC only plus IF into R plus I reference into R. Then I got here. This is positive only plus VBE. Then I am entering negative. Okay, everything is correct. Then if I take this on the other side, I have VCC plus VE minus VBE. Okay, by R equal to I reference. Okay, the same current is flowing here, will be flowing here. Okay, right. That's it. Okay. This is the equation for I reference whenever there is a two voltage sources connected. That means two supplies, individual supplies. Okay. So these are the important 5 cases of current sources. Okay. That means they are current mirrors. The next lecture we'll see what is Widlar current mirror. Then we'll go to the problems. That's all for this video. Thank you.